Hey everybody, welcome back to Young Engineers of Today. So we're going to do our final bit for SketchUp, which is actually mostly about 3D printing. It's not too terribly long, but we'll spend some time with it, and then we will be done with that. Really, I mean, we there isn't anything lined up next yet. So as it stands right now, this is not obviously not the end of the class, but this is the end of the material that we have prepared so far. After that, we might move on to OpenRocket. Maybe we might move on to uh, cybersecurity. We might do who knows what. But, you know, what's life without a little bit of suspense and surprise, right? So anyway, yeah, we're just going to finish up with SketchUp today. It might be a little bit shorter than usual, and I apologize. I know that that's always kind of disappointing when potentially disappointing. I mean, I don't know you guys. You may hate these, but it's always kind of disappointing when the classes are shorter than usual. Um, and again, I do apologize for that. You guys tend to go through the material pretty quickly, though, so there is that. That always makes it a lot easier to just sort of make tons of progress in a day. But anyway, let's go ahead and let's actually spend some time talking about 3D printing. So we did the 3D warehouse thing last time, where basically I just opened up a good lord. I don't know who made this, but it really stand to. Anyway, the 3D warehouse last time around, which is basically just 3D models that people put up for others to use. So there was that house. It was made up of other things as well. There were cars and stuff like that. SketchUp is very popular for architectural design, so you'll find a lot of buildings in SketchUp and floor plans and things like that. But really, anything that's made in SketchUp can be shared on the 3D warehouse for other people to then download and incorporate into their designs. So that is one of the nice things about SketchUp, is the ability to sort of collaborate and generate more complex models. Oh, nice. They came in today? Excellent. You should tell me what you got. I already some parts on Newegg, but they were a hard drive. Oh, 1050 Ti. Nice. That's pretty awesome. Anyway, yes. So it's a way for creators to collaborate and generate more complex models, because you don't have to create everything from scratch. You can incorporate bits and pieces from things that other people have made and then build upon those in order to generate your model. And we spent some time looking at it, but so then I sort of brought up the thing of how do we take our 3D model and turn it into an actual 3D object. Um, in order to do it, you have to convert your file from SketchUp to STL. So let me go ahead and actually open up SketchUp, and I can show you guys that process in case you ever, you continue with SketchUp and you're ever curious as to how to convert it into a model for 3D printing. Go ahead and open up SketchUp. 3D modeling programs always tend to take their sweet time. Oh, right. Oh. Anyway, we'll go ahead and open up our template file. I forgot to save it. Well, let's just assume that this is the completed product. We wanted a partially ruined temple because, you know, why not? So first things first, you actually have to take what you want to be turned into a 3D printed model and make it a group. So now this entire thing has been turned into a group. If we wanted to, we could move it around and everything will move as a single group, and we could scale it and everything will scale as a single group. It'll even invert and scale, which is kind of hilarious. Anyway, yeah, we make it a single group so that the entire set of geometry is considered to be one object. Then once that's done, we'll actually have to get an extension in order to convert this to an STL file. So if you go up to Window at the top, you'll see you've got the default tray, submenu, got Manage Trays, New Trays, Model Info, Preferences, 3D Warehouse, Extension Manager, Ruby Console, Component Options, Component Attributes, and Photo Textures, just a whole bunch of different stuff. We're interested in the Extension Warehouse. We looked at the 3D Warehouse before, which is a warehouse of 3D models. We're now interested in the Extension Warehouse, which will basically list all of the extensions that you can use for SketchUp. And what these do is they're just basically bits of code that expand the functionality of SketchUp, which is useful for us. We want to expand the functionality of SketchUp. We want to make it so that it can turn SketchUp files, SKP files, into STL files or stereolithography files, which are good for 3D printing. And in fact, if we look at the top extensions over here, we see we've got 1001-bit tools, SketchUp STL, V-Ray for SketchUp, blah, 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 blah. But SketchUp STL, perfect. It's exactly what we want. Description, import and export STL files for 3D printing. And just some talking about what exactly it's meant to do. Basically, it's creating a model that you can export to something like Thingiverse. Perfect. Or, you know, to a 3D printer. Now, up here, it's going to have a download button in red. If this were a paid thing, you would have to pay some money first before that would become a download button. We're not interested in paying for anything. SketchUp STL is free. That's just what we want. So we're going to go ahead and click the download here. It's going to ask us to sign into SketchUp. I think I already have one. If you are not comfortable right now with signing in with your Google information, you're more than welcome to just belay this. I need to have that information. Boo. You're more than welcome to not delay this step until some point in the future when you want to fine, convert a SketchUp file into an STL file for 3D printing. So the download button has turned into an install button because I went ahead and signed in with my credentials. It'll ask me if I want to install the extension. I'll say yes. And it's a very good warning that pops up. It says that this extension will allow access to your file system on your computer. Be very careful, you know, don't give permission to this sort of thing lightly. Which is honestly something you should keep in mind at all the time. But this is a trusted extension. This is actually, I believe this was made by, yeah, it was made by the SketchUp team, I believe. Oh, that's hosted by the SketchUp team. Okay, so anyway, yeah, basically it gives you the ability to, in order to give you the ability to convert it to STL files, it needs to be able to write to your file system. Makes sense, right? It needs to be able to read a file and convert it, basically make a copy and turn it into an STL file and place it on your computer. So that's why it gives you that warning about it needs permission in order to access your file system, or you're giving it permission to access your file system by downloading it. But regardless, it is a good warning to have, and again, it's something that you should be mindful of all the time. Anyway, now that the button has turned into an uninstall button, we can verify that it is in fact installed. So that is actually most of the process. There's just basically one more step, and what that is, okay, and then we need to, yep, that's all it is. Okay, so we've got our template grouped. We just go up to File and click Export STL, and then it'll ask us, export only current selection. We can do the whole thing. We can export the unit in meters or centimeters or millimeters or inches or feet. We're going to use model units. That's just a good default. The file format is either ASCII or binary. What that basically means is, so if we were to look at an STL file, it's different from a G-code, but basically it's just a set of instructions for points and shapes and stuff like that that almost kind of look like mathematical equations. Most STL readers and STL writers write in ASCII, which is characters, letters and numbers, and parentheses and commas and stuff like that, like the stuff that you type with on your computer, essentially, in English. Some, however, will only take binary, which is just basically the same thing. It's all that ASCII stuff, but converted to binary ones and zeros. But it's generally more common, though, for ASCII, so you don't have to worry about it too much. You can save it as temple.stl in your documents. And then if we were to navigate to that folder, I'm about to sneeze. Thank you, Liam. It never actually happened, annoyingly. I muted the mic and everything, and I was getting ready, and then no sneeze. But I appreciate it anyway. So let's see here. I am locating the STL file, and I don't understand why it's showing in ginormous icon mode. We should fix that view as a list. And actually, if we go to the very end over here on this, you can see temple.stl, and it's got a Meshmixer icon because I have Meshmixer installed on this computer. But this is it's probably going to have like a generic file icon for you guys, just because you probably don't have Meshmixer installed. Either that, or it's going to take the icon of whatever 3D printing software that you use, or just it's however the STL file is interpreted. But as we can see right here, we got an STL file. So what can you do with that kind of stuff? Well, I showed you this stuff last time around, the 3D printing pictures, which are pretty neat, and this is all from a very, very professional 3D printer. I mean, it's probably still a hobbyist 3D printer, but this is high quality stuff. Like this Eiffel Tower, the detail on it is insane. The little cross beams and stuff like that on the girders. The trident for Poseidon. I'm assuming that's Poseidon or Neptune. The birds in the bird cages, the weird butterfly bow tie looking thing, this bracelets, and then this rook. And again, you might be like, well, it's not really all of that, impressive, until you realize that these little bird cages right here are the size of a quarter. So if you have a quarter, handy, you can basically get a sense of the scale. The fact that there's all these details and stuff like that on, like, you can actually see Neptune's face and there's some hair and some musculature and things like that on something that is maybe an inch and a half tall, maybe. I don't know, I want to say a quarter is a little bit less than an inch in diameter, but that thing has got a lot of detail on it for something very small. Not trying to diss 3D printers, I just want to temper your expectations if you've never seen something 3D printed before. It's not exactly going to look this nice and neat, at least now. In the future, anything goes. Let's see what 3D printers are going to be like 5-10 years from now, and how fast they print and how good they look and everything like that. But as it stands right now, unless and these prints probably also take like a few hours in order to have that sort of precision. In the future, we might have faster and more accurate 3D printers that can print something out like this in a matter of, I don't know, half an hour, 45 minutes, and have it look good. Anyway, that's neither here nor there. 3D printing is used for, well, an increasing number of things. 3D printing used to be a hobby thing. Now it's starting to become, now people are starting to figure out uses for a 3D printer. There are people who print out artificial limbs with a 3D printer, like hands and arms and stuff like that. And they provide these 3D printed artificial limbs to people in poorer regions so that, at least they have something. Some of these 3D printed limbs even have a minor amount of functionality, like you can bend the fingers and stuff like that. For a while, there was that 3D printed gun, which was popular. I don't recommend doing anything like that. But it was meant to be a statement. People were worried about, guns being confiscated and stuff like that. Another conversation for another time. People are talking about creating furniture and items that you would purchase that the parts could be replaced by a home 3D printer. So let's say like a part on your chair breaks. Well, you can go to the website of the manufacturer for the chair, download an STL file, that's the part you need, print it out on the 3D printer, replace it on your chair, and boom, fixed. Just like that. That I think is kind of neato. So there are uses for 3D printers that are sort of starting to come to the forefront, and I think you guys will be right at the right time to really start experiencing these changes and taking advantage of them and seeing where they go and stuff like that. 3D printing is good for bone repair as well. I mean, this is a 3D printed skull. It's also a 3D printed patch on a skull, which is good for medical science. Again, because when you do something like crack your skull, a lot of times it's a very, very long and very, very slow and very painful healing process. And 3D printing can help to alleviate that. Obviously not make it 100% fine, but it will, it can help speed along the process. I've showed these pictures actually last time around, I remember, but I kind of want to go over them again. 3D printed cars could certainly be a thing of the future. This guy wants to 3D print cars so that they're cheaper and faster to manufacture. They have basically a better safety record because it's made of fewer parts. The car is all basically, the body of the car is more or less one part as opposed to being multiple parts, which increases reliability and strength because they're a lot of times the weakest link in something you build is the joint between two separate objects, like in a building, where several girders meet, or the top and side of a windowsill. Those would be like the weakest parts or something like that. Not specifically those things, but just in general, because joints tend to be the weakest part of any sort of construction. So by reducing the number of parts that make up an object, you increase its strength. which this guy's, hoping to accomplish with a 3D printed car. Plus, it would look funky because 3D printing allows you to create unusual shapes for an object. 3D printing houses is certainly a thing. There have been initiatives to 3D print temporary housing and disaster relief housing and stuff like that. So either displaced people because of natural disasters or homeless people because of life circumstances can at least have some place with a roof over their head. And even, as it gets better, they could even get things like running water hooked up to it and power and heat and things like that, so that they can live like you and I do. Granted, it's going to be less square footage, but regardless, it solves where it helps to. It doesn't. There's no silver bullet for any large problem. A lot of times, they're a result of many different factors coming together and combining in order to create one large problem, like, for instance, homelessness or hunger or things like that. So to say that this would solve it is disingenuous because, again, there is no one solution to a very complex problem. A lot of times you need to use multiple solutions, but this is something that would help alleviate that issue. This is something that would help reduce the number of homeless people and displaced people and things like that. And it would, just improve their quality of life, which is something you really can't say no to, right? So there you go. 3D printing can also generate housing for people. Now, this is something else. They're looking to incorporate 3D printing into things like moon settlements and stuff like that. Basically, you can suck up a bunch of regolith and combine it with some water and cook it and stuff like that, and sort of make like a moon concrete, and then print it out in order to generate more permanent settlements on the moon that people could then live in. That would be better defense against cosmic radiation and stuff like that. So that's another interesting idea. And the fact that it would be something that's printed means that it requires less effort on the part of the astronauts on the moon, settlers, whatever. It is a more permanent thing because, again, it's made out of fewer parts, as opposed to just like a bunch of bricks or something like that. And it would be easier, potentially. So yeah, 3D printing in general. What is 3D printing? How does it work? Examples, a brief history, and open source 3D printing options. So 3D printing is known as something called additive manufacturing. Additive manufacturing is, well, there's additive and there's subtractive manufacturing. So subtractive manufacturing is something like a CNC machine where you start out with an amount of material, like you might have like a cylinder of metal or something like that, and then you basically cut away material until you have the shape that you want. Maybe you're trying to make, I don't know, like a joint or a rod or something like that, and you would cut away material until you have everything to the exact specifications. Like lathes are subtractive manufacturing. Additive manufacturing is where you basically start with nothing, and then you add material into the shape that you want. So yeah, 3D printing is additive manufacturing because you're starting out with an empty 3D printing bed, and then you're adding plastics to it, or metals, or whatever, until you have the object that you want. You can think of Jello molds as additive manufacturing, kind of, cooking in general is kind of additive manufacturing, although that sounds kind of weird to say. But regardless, 3D printing is an example of additive manufacturing, where you're creating something by adding stuff. It's also the process of making a 3D solid object of almost any shape from a digital model. You guys knew that, though. Nothing new. 3D printing basically works through 3 steps. It's designed on the computer using 3D modeling software. It's then sent to the 3D printer, and then the 3D printer, well, essentially at some point between its design and being sent to the 3D printer, it's the model is sort of cut into a whole bunch of very thin layers that are stacked on top of one another. And the machine interprets those as instructions, and so it basically follows, it looks at each layer, each little thin layer that you slice the model out of, or model into, and constructs the model layer by layer. So it starts at the bottom layer and, basically, what am I trying to say? Squirts out some plastic in the shape that it needs to, and then it moves up a fraction of an inch, a very, very tiny fraction of an inch, and then it works on the next layer, replicates the next layer, and then the next layer, and then the next layer, and the next layer, and the next layer, and the next layer, and the next layer. So if you ever look at 3D printed stuff, generally a lot of stuff done with modern commercial 3D printers, especially if it's a very fast print, it'll be ridgy or bumpy. You'll notice that there are grooves all in one direction across the 3D model, and that's how you can tell how the 3D model was printed. Like, let's see here. Let me see if actually, because I didn't actually notice any. Yeah, there aren't really any visible grooves on these. So let me see here. All right, you can sort of see it in this picture. You probably can't with the bit rate that I'm probably sending to you guys, but if I were to, I don't know, grab a dark blue pen here, and you were to look at this very closely, you see that there are a whole bunch of different lines, all right, like up against one another, much, much closer than I'm actually drawing. This is just the best that my limited hand-eye coordination can provide for you guys, and the thickness of the pen. Wow. No, they'd all be parallel lines. And by looking at this, we know that basically it sat on the 3D print bed like that, and it started out at the bottoms of the wheels, and then it had another layer on top of that, another layer on top of that, another layer on top of that, blah, 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 so on and so forth, and it just gradually moved its way up until eventually it got to the point where, it was like printing the top of the car, and then it was done. No, 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 no. No, that would be awesome, but that would be so much plastic. Yeah. No, these are just, I think these are probably, I mean, they could be pretty sizable because they look like they're pretty decently sized. Like maybe you could be able to pick one up in your hand or something like that, and like it would be about the size of like if I were to draw a human hand wrapped around this thing. I think if I were to hazard a guess, it would probably be about this big. Look at that hand, that wonderful hand. Yeah, look at that. Got a thumb and everything. Let me draw the thumbnail. Woo! All right, now I shouldn't push my luck. I'm done drawing hands. Now, just for funsies. Look at that hand. Anyway, wow, okay. Erase. It's gone. So that can give you an idea of how a 3D model was printed just by looking at the lines. I know, super exciting. It's considered distinct because it uses an additive process to create items as opposed to a subtractive process, which is actually something that we've been. Subtractive process is an older method of manufacturing using materials and stuff like that compared to additive, especially when it comes to computer-controlled manufacturing processes. You know, you think about it like you start out with a piece of sheet metal and you cut holes into it and bend it into the shape that you want, or you start out with a log and you cut it up into planks, or you start out with, you know, start out with some like nickel or something like that, and you know, shear off bits of it in order to create a machine piece, or marble and chip away stuff in order to create a sculpture. You know, additive processes have existed for a fairly long time as well. Think pouring concrete into a mold in order to give it a specific shape. But it's certainly not as widespread and utilized as subtractive processes are, especially when we're referring to computer-controlled manufacturing processes. So the difference in the main types of 3D printing mostly come down to how those layers are assembled. Let's just move this up a little bit so it's no longer. There we go. Here are basically some different things that have been 3D printed. A guitar body, just a piece of art. This is a face, but it's actually made out of chocolate. So weird, but also tasty. And a titanium jawbone. So, you know, for jawbone replacement and stuff like that. Uh, 3D printing pancakes. So basically 3D printing starts with Chuck Hull, who was the inventor of the stereolithography format, for computers at least. He created the first 3D printing machine as well. That's as far as that goes, okay. But that's what STL stands for, stereolithography, which is basically just a... Hold on, let me get a more official definition of stereolithography for you. So it is a technique or process for creating three-dimensional objects in which a computer-controlled moving laser beam is used to build up the required structure layer by layer from a liquid polymer that hardens on contact with laser lights. So that's different from 3D printing, but that's where 3D printing basically has its origins. So basically a light-sensitive polymer that's a liquid gets blasted with lasers and turns hard. So it's kind of cool, kind of dramatic sounding. So, you know, since then, devices have continued to get smaller, faster, and cheaper, but the STL file format can also be used for 3D printers because stereolithography has a very similar sort of control scheme to 3D printing, whereas with stereolithography, you are pulsing a laser a certain distance into a material. 3D printing, you are depositing plastic a certain, you know, distance away from a base. As far as open source printing is concerned, there's a lot of options, but, you know, a couple we're going to look at. We got RepRap, which is interesting because it's actually the first self-replicating manufacturing machine. It can print another fully working version of itself, with some caveats. You can't really 3D print motors because a lot of the material that a RepRap will work in is non-conductive and not magnetic, which makes it difficult in order to make something like a motor. So, you know, it's sort of a marketing hype to say that it can print another fully working version of itself, because it can't. You can't print the motors that it needs. Can't print the servos that it needs. It can't print the, you know, the computer controller inside that it needs. It can print everything else though, including, you know, the print head and, well, no, it can't even do that. No, it can't do that because the print head needs to be able to be, needs to stay solid while the material melts, and it can't print a heating element either. So, yeah, I know it's disappointing to hear, but that is sort of the reality of a statement like that is it's not actually able to print a fully working version of itself, unfortunately. The designs for the machines, though, are free to share and use, including, you know, well, the design of the machine itself. So they do include an STL file on their website, a G-code file on their website of their own 3D printer, so that you could actually print out all of the parts and then, you know, just sort of order the other things that you need in order to create another 3D printer. In addition to any other designs that, you know, work with RepRap, you can share those designs on the website along with other people. Then there's the MakerBot Replicator. The founders are from the Maker community, which is, you know, sort of a vague thing, but as opposed to, you know, corporately funded and stuff like that. They provide completed 3D printers, and they helped create Thingiverse. So if you guys have ever visited Thingiverse before, you can thank, among other people, the MakerBot people for it. And nah, that's not relevant. But if you haven't been to Thingiverse before, Thingiverse is pretty incredible. Thingiverse is nothing but a collection of STL and G-code files and stuff like that in order to for printing out on a 3D printer. So what we can do is we can go over to the Explore thing. We can explore things. You can see there's Luke's snowspeeder, but made out of Lego. So you could actually 3D print a Lego snowspeeder if you wanted to. You could print out a regular snowspeeder as well, or airspeeder, I guess. So you could have, you know, one for the X-Wing game, or you could have a decently sized one that, you know, some assembly required. This looks more like a CNC machine. They probably cut all the parts out in the CNC machine and then folded them together in order to create this thing, which, you know, it's pretty awesome. Yep, there you go. More CNC stuff. Thingiverse basically has all kinds of stuff. You've got stuff for Warhammer 40K. Here's a diorama. Here's a zip mount for an H8 Mini, whatever that is. A fidgeting toy. Houses random things like a Destiny, basically looks like a paperweight. Large what? Oh, corrected. A pipe for fluting. Just all kinds of different stuff. A sword. The phrase "So say we all" from Battlestar Galactica. There's basically, if you can imagine it, Thingiverse probably has a version of it sitting on its servers. If not, then you're more than welcome to make something yourself in like SketchUp or something like that, and then upload it to Thingiverse. So somebody else who would inevitably come along and want probably whatever you're looking for too, would be able to find your creation to be like, oh, cool, I can use this. It's all licensed under, basically open source, new license. So it's free to use, it's free to distribute, it's free to modify, which is it's pretty awesome. And that's actually one of the greatest promises of the 3D printing, era, is the ability to share designs and stuff like that um, with others and distribute, the sort of a mass distribution of inventions and creations and stuff like that using information. Anyway, so that's going to do it for today. We'll get started on another subject on Monday. Hope you guys are looking forward to that, because who knows what it could be. It could be anything. I think it's pretty cool, but we'll see. Anyway, I'm going to go ahead and do the poll questions, and then we'll question and answer time it up. And then, just as the deal always has been, if you don't have any questions after we're done with the poll questions, you're more than welcome to head out. Otherwise, you're more than welcome to ask any questions that you have on your mind. And, have a wonderful weekend, and we'll see you on Monday.